Today's lesson, we are going to be doing some word problems, reading them, making some conclusions, and then graphing some data. So the biggest thing with word problems where you need to start is realizing there's always an independent and a dependent variable in all of our word problems that require graphing. So the independent will always control the dependent. So for example, we have a percent of blood flow and number of days. So you have to ask yourself which one controls the other. And obviously, you can't control time. So anytime you have time in a problem, that is the independent or the X variable, because time will go on no matter what you do. But it does affect what happens after that. So we're just going to do a little practice. I'm going to do yellow for independent and green for dependent. So it says salary earned, amount of time. So right there, time is your independent and salary is your dependent. Your chance of getting lung cancer and smoking, obviously smoking controls the chance of getting lung cancer. And then grades and amount of time studying. So there's time again, and you'll see that in so many problems. And then obviously your grades are going to be controlled by how much time you spend studying. So then we have a graph over here on the right, and you're just supposed to kind of read the graph and then tell a story from it. So just making sure we understand what's going on here. We have time versus the speed of a car. So you just kind of read what's going on here. Okay, the speed is going up and then it stays the same. And then you slow down. And right here, even though it's going on, okay, time is going on, but your speed is 0, 0, 0, 0. So you are stopped for a certain amount of minutes. So this could be something as simple as the story could be I got in my car, I merged onto a highway, I drove, and then I got off the highway and had to stop at a stop sign. So it's usually just good to kind of write down what's going on at each point of change in the graph. The next problem says something about you're at Go Kart World. Each ride costs $4. You're going to go with 7 friends. You each get 1 ride. And that says the cost is a function of rides. That means that the number of rides controls your cost. And that kind of makes sense. Obviously, the more rides you take, the more money you pay. So what I'd like to do is the number of rides is going to be equal to the number of friends. So for 1 friend, 2 people, 3, 4, 5, 6, up to 7 people. And then each person's $4, so it makes sense to count by 4s. So now we're just going to plot what we get. So if I just have 1 person ride, that will cost $4. If 2 people go for a ride, that's $8. 3 people is $12, etc. So we're just going to plot those points, and we should see a pattern. 1 to 4, 2 to 8, 3 to 12, and we could keep going all the way up to 7 friends. Okay, so there's my function relation. All right, number 3, it says every 2 shirts you buy for $15, you get a third free. So it would probably make sense because there's kind of a deal going on to make a table of ordered pairs and then just plot them on the graph so you don't get confused. So let's just assume that they're selling 2 shirts in a little package. So you can't just rip the package apart and take 1 shirt from it. So you have to buy in increments of 2. So if you want 2 shirts, it's going to cost you $15. But if you purchase 2 shirts, you get a free third shirt. So you're getting actually 3 shirts for $15. And then the next group would put you at 4 shirts because you have to buy them by the 2s. You just get a free third one every time. That'll cost you $30, so $15 more for 2 more. But you would also get another shirt without changing what you pay. And we could keep doing this. So if the next group, if you bought another pack, that's 6 shirts for $45. But you would get a 7th shirt then for free. 8 shirts, you would have to pay $60. 9 shirts, still $60 because you get that one for free. 10 shirts would cost you $75. which really means you get an 11th shirt for $75. So you might as well get your free shirt every time. So once you make this ordered pair list, it's going to be really easy to graph. You just go through and do it. So we're going to go to 215, 315, 430, 5,30, 645, 745. So you should see kind of a pattern going on here. It looks like a little step chart of some sort. And so on. So this is kind of what your graph looks like. All right, the next example talks about height of a baseball every second. So obviously time is not controllable, so that's your independent. Height would be your y-axis or your dependent. So it says to draw a graph of the data, and this is something you have to figure out. You have to look at your numbers and then figure out what kind of graph would make sense. What should I count by? So for my x values, I can totally count by ones because it only goes up 4. But for my y values, the smallest number I have is 30, and I need to get up to 145. So in my head, I'm just like, will 30s work? 30, 60, 90, 120. No, 30s don't work. Could I do 50s? 50, 100, 150, 200. I could do 50s. So it doesn't really matter as long as you have enough room to get all your data graphed. You have to pick numbers that would make some sense. So obviously your graph is just going to be a very, very tight estimate. So we have 1,62, that's somewhere here. We have 2, 145, which is somewhere maybe here, right, close to 150. 375, that's going to be kind of like right here, halfway between 50 and 100. And 4,30, that's going to be under 50. So our graph looks something like that. Then it says, what is the dependent variable? Well, your dependent is your y-axis. So in this case, it's height. And it says, what is the height after 3 seconds? So well, it tells you right here, 3 seconds. It's going to be 75. I assume it's feet. All right, and then it says, what's the domain? So that means, what are all the x values? So the way we do this is we write d equals, and then all my domains are 1, 2, 3, and 4. Then we have to do the range, and just be careful. You don't want to use the values you put on your y-axis because that wasn't the actual values of the y-coordinates. So we want to always use our ordered pairs to answer this. So it looks like we have 62, 145, 75, and 30 as our range. All right, number 1, it looks like it shows how long a baby is versus the age. So obviously age is going to be independent. So age is independent because you can't control that. Your length, however, is going to be dependent on your age. Then it says, okay, once you take this table and make a list of ordered pairs, so that should be kind of simple. 0, 20, 121, 223, 323, and 424. So we did that, which is great. And that says draw a graph showing the relationship. So they already labeled the coordinate planes for us. Now we just plot the points. So we have 0, 20, 121, and so on. So there's our graph. And that's it for that one. All right, the last one says you have a car, how old it is versus value. So obviously age is time. Time is always independent. And dependent would obviously be the value. And that makes sense. Value depends on how old the car is. So it does not make us do ordered pairs for this one. It just says draw a graph. So they're assuming you can do the ordered pairs in your head. So we have to do 0, 20,000, which is right here. Remember, it says value in thousands. So each of these, you have to say 1,000 behind. 1 and 18, 2 and 16, 3 and 14, and 4 and 13. And we could keep going. So it looks like as this particular car gets older, its value continues to decrease.